Hello everyone, Gaza Mutkarsh, and I welcome you all to the session on Python fundamentals for data tasks. So guys, let's have a look at the agenda for this session. So before proceeding with this session's agenda, previously I'd like to give you the recap of all the topics that we have covered. In the previous sessions, we have discussed about variables, data types, operators, followed by conditional statements, loops, and loop control statements. So the agenda for this session includes, we'll be discussing about functions in Python, how to define the function syntax, how to create user defined functions, the different type of built-in functions that we have. We'll also be discussing the types of functions, namely the parameterized and non-parameterized functions. And we shall also be discussing how to utilize the return keyword in Python. And followed by that, we'll be proceeding with modular scripts. So guys, let's head over to the Jupyter screen. So guys, let's start with the topic functions. So what are functions in Python? A function is a block of organized reusable code that performs a specific task, right? So we do have n number of predefined or inbuilt functions. For example, so far we have been using, let's say, print function, type function, length function. Now all these functions we did not create. They were already available for our use. So they are called the built-in functions. Alright, now we can create our own functions to perform a specified or customized task. They are referred to as the user defined functions. So why do we use the functions in the first place? Because they provide code reusability, and at the same time we can call the function n number of times. So we don't have to write the same code over and over again. So there's another aspect for which we can utilize functions. Now functions do help to break down, let's say, larger programs into smaller manageable chunks, improving the code readability and reusability. All right. So functions overall, they facilitate reusability of the code, and based on the same fact, they prevent code repetition. So we don't have to write, let's say I've created a function of 10 lines. So I don't have to write those 10 lines over and over again. Rather, I'd be using the function name. हम function name को ही use कर लेंगे तो वो same काम आपका हो जाएगा, right? Now, let's understand the different types of functions that we have. In Python, we have two types of functions, namely the built-in functions. So they are the functions that are readily available in Python, such as print, length, type. These are the types of functions that we call as built-in functions. Then on top of it, we have another type of functions which is referred to as the user-defined functions, or we can call them the custom functions. So they are the functions created by the programmer for specific tasks. All right. Now, let me show you a couple of examples of these user-defined functions. So far, we have discussed the string data type, right? So I'm going to give you example of built-in functions. Built-in function examples. So let's see a couple of examples of strings. So for instance, I'm having a string. I'm having two strings, s1, s2. I'm having hello, and then I'm having Google. All right. Now on these strings, I can perform, let's say, functions like upper. So it will convert it into uppercase. I can perform operations such as lower. All right. So these are some basic functions. Likewise, we have n number of other functions. We can, let's say, check if the string is starting with a particular character, if the string is ending with a particular character. For instance, I want to check s1 dot starts with. Is it starting with, let's say, h? Is s1 starting with h? So if it is true, it will give me this is starts with. Yes. Is it starting with s? Yes. Likewise, I can check, is it ending with e? This is ends with. Is it ending with e? Yes. Now this is s1. S1 is not ending with e, right? So I'm getting false. But is s2 ending with e? Let's check this. Yes, s2 is ending with e, right? So I'm getting true. Likewise, I can demonstrate a couple of other functions. For example, suppose I'm having this. Over here, I'm writing data science and data analysis. All right. Now, in this sentence, I want to replace the word data maybe with, let's say, another term. Okay. Instead of data, let's try to replace analysis. All right. So over here I can write S3 dot replace analysis with I'm replacing it with visualization. Just observe this. So in S3, if I have any occurrence of analysis, it will be replaced with visualization. So I can store this as well. I can store this in another variable as well, and then I can use this variable like this. Does this change the original string? No, it doesn't. So the original string remains as it is. So guys, likewise, we do have string based functions to get rid of extra spaces at the left, at the right. So we do have a number of functions. For example, these are the common functions that we have, right? Starts with, ends with, format. We can check if it is alphanumeric. We can check if the string is alphabet, contains only alphabet. If it contains digit, if it contains lower characters, if it contains upper characters. All right, all these let's say functionalities we can check. All right, I can also count how many times a particular string has occurred, a particular character is repeating. So suppose I want to count how many times is the word data repeating. So how many times is the word data repeating? It is repeating twice. Likewise, I want to know, let's say, what is the count of the alphabet A? How many times is A repeating? So A is repeating 6 times. I can also fetch the index. How do I fetch the index? Suppose I want to fetch the index for T. So where is the first occurrence of T? T is present at 0, 1, 2. It is present at the index 2. Alright, so guys, this is how we can utilize a couple of built-in functions. Now, when we talk about user-defined functions, so defining or creating a user-defined function consists of two parts. The first part is the function calling. The first part is the function definition. The second part is the function calling. All right. So functions are called using the function name. So function को define कैसे करना है? Let's understand this. So this is the general syntax. The syntax goes like this. First we have to write the def keyword followed by the function name, and then maybe if there are any arguments we can mention them. All right, I can mention n number of arguments. Then we have to define the function body, and then we have to call the function. So this part is referred to as function definition. This is the first part. This is called the function definition, and the second part is function calling. All right, how do we call the function? Using the function name. So if there are arguments, we have to pass the arguments as well. So based on whether the arguments are present or not, again there are two types of functions. We can call them parameterized and non-parameterized functions. All right, so I'll give you examples of both. Non-parameterized function. Suppose I want to find sum of two numbers. So I can define it like this. Maybe a comma b is 5 comma 7. All right, now I want to print a plus b. So it is always going to give the output as 12, right? How do we call the function? See, this is how I have defined the function. Def keyword, which is used to indicate that we are creating a function, followed by the function name. This is the function name. A and B will be used as, let's say, the values based on which the function output is tabulated, and the function output is a plus b. So I can call this function like this. All right. Over here I'm calling this function. It is always going to generate the output 12. Now I don't want the same output a and b always. So what am I going to do? I'm using these variables outside the function. All right. So this is where I've defined the function. Now to call them, over here I'm writing a comma b is 5 comma let's say 18. So now what will be the output? The output will be 23. Okay, let's make it 17. So the output is 22. Now again I want to call this, but I want to add two different numbers, not 5 and 17. So maybe over here I'm writing let's say a comma b as 4 comma 19, 4 comma maybe 28. Now if I call this, now I'm getting 32. Why? Because a and b have been changed to 4 and 32. So this is how we can define non-parameterized function. Now this is a very basic example. Why I'm saying so? Because we have not passed any arguments or parameters. We have not used any for loop. We have not used any if else condition. Let's try to understand a slightly more let's say complex example. So for that, I'm using parameterized functions. Suppose I want to find, let's say, find all factors of a number n. For a given number n, I want to find all its factors. So how do we calculate this? For this, over here I'm writing def find factors of n, right? So n is the argument. N is the argument or the parameter. Now, how do I proceed? For I in range, I want all the factors of n, right? For I in range, let's say over here I'm writing length of n. So if n is maybe, let's say 12, so length of n would be 12. So I would vary from, if n is 12, I'm considering n is 12. So I would vary from 0, 1, 2, 3 all the way up to 11. All right. Now, because I want to count the factor of 12, so 12 is also a factor of 12. So I've written 11 plus 1. So this goes all the way up to 12. Now, what is my logic? My logic is I'm iterating from, let's say 1 all the way from 1 to 12, right? I'm iterating from 1 to 12. Now, to find the factors, I need to ensure that the number n is divisible by these numbers, right? So if it is divisible, it is a factor. So over here I can check if n mod I double equal to 0. If this is the case, then I can simply print I. So these will be the factors. All right, these are the factors. So let's call this function. Now if I call this with 12, just a minute. Okay, because it is an integer, so it has no length. So over here what I'm going to do, I'm directly going to pass n plus 1. All right, over here I'm directly going to pass n plus 1, and it is starting from 1. See, these are the factors of 12. So starting from I1 to n plus 1. So this is 1 to all the way up to 13. So if it is 1 to 13, the iteration will proceed till 12, right? The iteration is going to proceed till 12. Reason being, what is the start? The start is 1, the end is 13, and the step size is going to be plus 1. Now, can I change this? Yes, it can be changed. If I change it to 24, see, even this is correct. If I change this to 50, even this is correct. Now, to further extend this, I want to display even and odd factors, right? I want to find the even and odd factors. Even and odd factors of a number n. Correct. So again, I'll be writing for I in range 1 to n plus 1, and if it is a factor, if let's say if n mod I double equal to 0, then again I'll be checking if this condition is true and if I mod 2 equal to 0. So these are the even factors, right? These are the even factors. I'll be printing I. Else I can print odd factor, and odd factor would be I as well. So maybe for, let's check for 18. See, odd factor is 1, even factor is, okay, let me change this. Yep, odd factor 1, even factor 2, odd factor 3, even factor 6, odd factor 9, and the even factor is 18. So this way we can distinguish, or let's say separate the even from the odd factors. So guys, I hope you are able to understand how we are defining the function and how we are utilizing it as well. Now, as far as the function arguments are concerned, there are two types of arguments. We have positional argument and then we have default argument. So over here, if I'm defining a function, suppose ABC. Now, over here I can pass something like this. So A and B are positional argument, right? In this example, A and B are positional arguments and C is default argument. Now, if I perform an operation such as this, A plus B plus C. So if no value is passed for C, its default value will be 4. 4 will be utilized. Let's check. Now, when I'm calling the function, I'm passing 2, 3, 5. So A is 2, B is 3, and C is 5. So the output is 10. But even if I don't pass, let's say C, it will still work. It will still work because the default C value that it will assume is 4. So C की यहाँ पे default value 4 हो जाएगी, right? In this example, as we can see, 2 plus 3 5, 5 plus 4 9. But A and B are mandatory. We cannot skip A and B. Maybe I'm passing 7 and 10. All right, so A will be 7 and B will be 10. So what about C? C will be 4 because that is the default. So positional arguments are those whose position is fixed and they are mentioned in the left to right direction, and then it is followed by the default arguments. So in left to right direction, first we have to define all the positional arguments and then followed by the default arguments. So default arguments are the arguments that are initialized with a default value. All right, so guys, this is how we can define a function with positional and default arguments as well. Now, next we have to understand the return keyword. So return is only used inside functions, and return has to be the last statement in the function, right? And return can only be used once in a function, let's say, except for the exception of maybe if you're using it in if, elif, else. And return cannot be used to generate a sequence. Return se hum sequence generate nahi kar sakte. So why are we essentially using the return? Because we want to store the function output. We are using, let's say, return keyword to store the function output, right? I'll give you an example. Suppose I want to greet someone. So greet name. And over here, what is my greeting message? I can simply write it like this. Return maybe welcome and welcome plus name. All right. So maybe space welcome plus name. So this is how I've defined a function. This is the greet function, right? Suppose I want to greet Virat. So I can simply write it like this. And what is my outcome? My outcome is welcome Virat. Now I can store this output. As of now, I've simply displayed it, but this has not been stored. To store this, I can use a variable. Because the function is returning something, so I need a container to store that information. Now if I print A, I'm getting the output as welcome Virat. All right, this is how it works. So return is used only inside the function. See, I've used the return keyword inside the function. It has to be the last statement. Anything written above it will be executed. For instance, if I'm writing, let's say hello world, so it will get executed, right? But if I write something below hello world, below the return, it won't get executed. If I write Python, so it won't get executed. Why? Because return is the last statement in the function. Anything written above it will be executed. Anything written below it won't get executed. And it can only be used once in a function. If I use it multiple times, suppose I'm returning maybe, let's say 10 into 2. All right, if I'm returning this, will it work? No, it's not going to work. So even we have discussed the third point, and return cannot be used to generate a sequence. So return does not have the capacity, let's say, to work around this. I'm creating a function 2 and n. So for I in range, let's say n. Now if I return I, so it will only give me the first value. First value will be 0, right? So now if I call this function and if I write 5, it is only going to return me 0. It cannot return a sequence. All right. So guys, this is how we can utilize return keyword in the function, and it's a way better approach. Let's say when we want to store the information that the function, that a particular function is returning. So guys, I hope these examples will help you better understand how to utilize functions. Next, moving forward, let's understand the concept of modular scripts. So in the functions also we have discussed that functions divide the code. Utilizing functions, हम code को modular chunks में divide कर सकते हैं, right? So this is where the concept of modular script comes into picture. So modular scripts refers to the practice of organizing code into modules. Code को हम modules में divide कर रहे हैं. Modules indicate that is separate files. All right. For example, even in the libraries that we'll be using in the upcoming sessions, such as pandas, maybe numpy, maybe matplotlib, maybe seaborn. So we'll see that there are a couple of modules involved, right? So modules refer to separate .py files. तो उन files में अगर हमने कुछ functions बना रखे हैं, so maybe we can import them into different file and utilize them. This is referred to as modular scripting. So modular script refers to the practice of organizing code into modules, essentially separate files, each for a specific purpose. So this improves the code readability, reusability, and maintainability. Now, Jupyter files have an extension of ipynb. So over here, we won't be able to, let's say, execute modular scripts. So for that, we'll be needing the VS Code. Here is the link to download VS Code. I'll show you the link. So if you're using Windows, maybe let's say some Linux version or Mac, you can just click on this, and or maybe you can click on download. Once you have the downloader, once you have the exe, just double click it and click on next and finish. It will take somewhere around 5 to 10 minutes and it will be installed. Then in the search bar, you have to search for the VS Code and it will open up. If you have added the path to the environment variable, even in VS Code, you will be successfully able to run the Python scripts. So guys, I have VS Code installed. So I'll be switching to the VS Code and I'll show you how we can create modular scripts. I'll be creating two files, let's say file 1 and file 2. Alright, maybe we can name them accordingly. And in file 1, we'll be creating a function, let's say, to solve a task. And in file 2, we'll be importing function from file 1. Alright, and we'll be calling the function. So this is going to be our objective, right? We'll be importing the function from file 1 and we'll be calling the function. So guys, I'm switching to the VS Code screen. So guys, currently we are in the VS Code. Now, how do we create files in VS Code? Over here, means this is the same folder into which I've stored all the Jupyter files that we have covered so far. So just click on this new file, right? If I click on this new file, I can call this, let's say function. Let's call this, okay, as of now, I'm calling it file1.py. I'm calling it file1.py. Suppose I want to grade student marks. All right, so basically I need to generate report. All right, I want to generate report based on the marks. All right, so what is my rule? If let's say over here I'm passing marks. So if marks is greater than 90, all right, what am I returning? Excellent. Now this is the case where we can use multiple return statement because I'll be utilizing if else. Else if marks, let's say marks greater than 90 and marks less than equal to 100. This is the boundary condition, I'll be returning excellent. If marks is greater than 80 and marks less than equal to 90. All right, this is elif. If this is the case, then what am I returning? I'm returning outstanding. All right, or maybe I can just replace them. Yep, and then we have elif. If marks is greater than maybe 70 and marks less than equal to 80, then I can return good. All right, if it is between 60 and 70, then fair. And elif, if it is between 50 and 60, then I can mention average. All right, elif. Now if the marks fall, let's say less than equal to 50, if it is less than 50, I'm simply mentioning poor. And else, if the marks is, let's say marks less than equal to 50 and maybe the marks is greater than equal to 0, then it is poor. Else if none of these conditions is true, then I can return invalid marks. All right, this is the function that I've created, generate report. So if the marks is greater than 90 and less than equal to 100, then outstanding. Greater than 80, less than equal to 90, excellent. Greater than 70, less than equal to 80, then good. If the marks are greater than 60 and less than equal to 70, then fair. If greater than 50, less than equal to 60, then average. If less than equal to 50 and greater than 0. Alright, maybe following the format that we have been using. Greater than equal to 0 and less than equal to 50. So if this is the case, then poor, otherwise invalid marks. So let's check this. Now I'm going to call the function, right? How? Generate report, and marks that I'm passing is 70. Okay, maybe 73. Now to call this function, this is the folder name. Now over here, I just need to write Python file1.py. All right. Okay, generate report marks. Just a moment. Let me check. File1.py. Yes, it seems correct. Okay, so because it is returning, I need to store the output in a variable. So I'm storing it in a variable and then I'm printing the variable, right? This is the report. This is the report that I have. So I've stored it in a variable and I'm printing the report. Now let's check this. Yeah, so currently the marks is 73. At 73, I'm getting good. At 34, what should I get? At 34, I'm getting poor. Now if I change this to maybe, let's say 85. Now what should be the output? At 85, I'm getting excellent, right? Now if I pass minus 45, okay, not over here. If over here I'm passing minus 45, then what will be the case? Now it's saying invalid marks, right? So we have covered couple of, let's say, marks over here. So clearly it's working. If I pass 96, then I should get outstanding, right? Yes. So as we can see, guys, this is working. Now all I need to do over here, currently I'm simply commenting this. Now I'll be creating another file. I'll call this file2, and in this file2 I'll be importing the function, right? So how do I import it? From file1 import, what was the function name? Generate report. Now I'm defining a marks over here. Suppose the marks is 50. All right, and the name is marks is maybe, let's say 87, and the student name is, let's say Karthik. All right, so how do I call the function now? So what would be my report? The report would be generate report marks. Now over here I can simply print name, scored, maybe let's say marks, and then let's say and has obtained the report. So what is the report? The report is this report. All right, so this is how I've imported the file. So from file1 import generate report, the marks is 87, the name is Karthik, and I wanted to store the report of Karthik in the variable called report. So name, scored, marks, and has obtained the report. This. So this is his report, right? This is his grades. All right, let's say, and has obtained the grade. This is the grade that I'll be representing. So now if I use file2, so I just need to pass python file2.py. So guys, as we can see, Karthik scored 87 and has obtained the grade excellent. Now if I simply change this, if I change this to, let's say 53, now what will be the change? Karthik scored 53 and has obtained the grade average. So guys, if I change the marks over here, accordingly the report will be changed. So this is how we have created separate modules, one module for defining the function and another module where I can import the function and utilize this. From file1 is referring to the file name, and then import generate report refers to the function created over here. So guys, this is how we can utilize modular scripts in Python. So I'm switching to the PPT. So guys, that brings us to the end of this session. In this session, we have discussed, we have understood how to create functions, how to write its syntax, how to create custom functions for solving a particular problem statement. We have also seen how to utilize the return keyword, and we have also worked with the modular scripts. So in the next session, we'll be discussing about file handling and user inputs. Thank you.